Well, we certainly know that we were hit 65 million years ago by a very large rock from space. Hollywood knows this with the two blockbusters, Armageddon and Deep Impact, so it must be true. It was really interesting. In '95, Spielberg sent his minions to a conference a number of us were attending about this particular hit. And indeed, there is great danger out there. We are surrounded by asteroids. Some become Earth crossing. Jupiter has a way of perturbing comets and sending them from stable orbits to Earth crossing orbits. We will get hit again. How big the hit will be is only a matter of time until we get something that's the same size that killed off the dinosaurs. Showed humanity last long enough, that is. But that size hit looks like only once in 100 million years or more. We haven't had a hit that size for the last 500 million years. So it does look like it's a rare event to have something that big, a 10-kilometer asteroid, hit us. Well, no, it's just the whole sense of when is it going to happen again. And it appears that most of the big mass extinctions have been caused by these nasty volcanic events. The last one didn't cause a mass extinction. It was in the tertiary period. This was in my own home state, Washington State, the Columbia River basalts. Out came all this basalt, this liquid lava, and a lot of carbon dioxide came out too, but not enough to cause the Earth to go into a really nasty mass extinction. The mass extinction is caused by the basalts, again, or simply by heating the world. Now, when you heat the world, you heat the poles more than you do the equatorial region. When that happens, you start losing circulation. The only reason you have wind now is you have a hot spot and a cold spot, and they're trying to equilibrate. Well, in ocean currents, same thing. You have a cold Arctic, a cold Antarctic, and then you warm them up. The ocean circulation systems dampen down. There's much less heat difference. So when we heated the poles to the point that there was no longer or only very sluggish ocean circulation, the oceans go anoxic. They lose their oxygen. They only keep oxygenated now because of this vigorous mixing. Well, even when you have oxygen in the atmosphere in contact with the surface, once you slow down any circulation, that whole basin can lose this oxygen. The Black Sea is the same case. It sits under a 21% oxygen atmosphere, and yet the Black Sea, except for the top several meters, is anoxic. It's black because it's producing a lot of sulfur-producing bacteria, and there's very nasty gases that are produced. We now think the big mass extinctions were caused by global anoxia. The oceans themselves so sluggish that the hydrogen sulfide bacteria are produced in huge areas of the ocean bottom, bubbles up to the surface, and starts killing things. Rotten egg killing. It would be extremely nasty. Hydrogen sulfide poisoning is a horrible death. 200 hydrogen sulfide molecules among 1 million air molecules is enough to kill a human. I mean, just breathing in 200 of those little things amid all the million you've got of oxygen, and boom, you're down, horribly down. So this is a really nasty poison, and it was certainly present in past oceans during these short-term global warming events. That's why it's really spooky what we're doing now.